Welcome to this video where we are going to solve a double integration question. All right, so the question reads, find the volume of the solid enclosed between the sphere, this one, and the cone z is equals to the root of x squared plus y squared. Okay, so for us to find the volume here, we have to follow a series of steps. Okay, so the first one is that we have to sketch these surfaces. Okay, after we sketch the surfaces, we have to find the curve of intersection of the two surfaces. Okay, curve of intersection. And then once we do that, okay, when we find this curve of intersection, we are going to project it. Okay, project it onto the XY plane or the floor. Okay, we're going to project it onto the floor or the XY plane. And then once we do that, now we are going to identify which of these two surfaces will be my upper surface, okay, and which one of the two will be my what? My lower surface. Once we do that, okay, we're going to use this projected surface onto the XY plane, okay, to convert our limits into polar coordinates. Okay, and once we convert into polar coordinates, we'll easily evaluate this what? Integral. Okay, so that's how we are going to move in trying to solve this question. All right, so let's start with the sketch. Okay, so the sketch starts with the sphere. Okay, so the sphere is not very hard to sketch. We can look at the cross sections. Okay, so we say in the XY plane, what are we going to be seeing? So here our Z will be 0. In the YZ plane, okay, what are we going to be seeing? Our X is 0. And in this XZ plane, what are we going to be seeing? My Y is what? 0. So we can come up with the sketches here. So if Z is 0 here, I'll just have X squared plus Y squared is equals to 1. That's just a circle. Okay, that's just a circle in the XY plane with center 0 and radius 1. So it will be somewhere there 1, 1, 1, 1. So it will be this circle here. So this is what I'll be seeing in the XY plane. And then to be the same for these other planes. Okay, because this is a sphere. All right, so this will be Z and then Y. And then I'll still have a circle there 1, 1, minus 1, 1. Okay, and then even in the XZ plane, I'm still going to have the same because Y will be 0 and then I'll have X squared plus Z squared is equals to 1. So the center will still be 0, 0. And then this will just be a circle with radius 1 like this. So these are the three circles that I'm seeing. Okay, so now I need to combine these in order to come up with what we call as the sphere. So the sphere, we're going to draw it in 3 coordinate system. Okay, so this will be my Z. Okay, and then this here will be my Y. Okay, this one will be my Y. And then I have to draw my X. Okay, let me get some straight line. So this will be my X here. Okay, so once I have my X, my Y, my Z, I can sketch this sphere. Okay, so this will be my X. So this sphere is just passing on 1, 1, 1 or negative 1, 1, 1. So I'll start with the one in the XY plane, the one that I can see on the floor. Okay, so I'll say that one should be this circle that I'm seeing there. Okay, so that should be the circle that I'm seeing. Let me draw it a bit better. Like that. Okay, so meaning that here I have minus 1, here I have 1, here I have 1, I have minus 1, I mean. No, I'm not drawing in the Z. Okay, I'm drawing this in the XY plane, right? So it means on the X I have 1 and minus 1, and then in the Y I have 1 and minus 1. Okay, that is better. Okay, and then now I need to draw another circle, but in the in the YZ plane. Okay, so YZ plane, this is my Y, this is my Z. Okay, so I'm going to say my 1 in the Z should be somewhere there. Okay, and then I have my -1 there. Okay, so I'm going to draw my circle, okay, in the YZ plane. Okay, so my circle will be something like this. Okay, to be something like that. Okay, and then I can also draw, it's not a perfect drawing, okay, but it will be something like that. And then I can also draw the circle that I can see in the XZ plane. So in the XZ plane, it will be this one here. Okay, let me try to draw it in another color to be this one here. Like that. So that would be like my sphere. Okay, I know the drawing is bad. Okay, but if I can just draw it on a separate axis, okay, the sphere will be something like that. And then we have that inner circle on the floor. Like that. Okay, so that will be my sphere. Okay, and then once I've sketched my sphere, I can try to sketch my cone, this one here, my cone. Okay, so we've sketched our sphere. Let's write a clean picture of the sphere somewhere there. Okay, so let me draw to my axis. Okay, so this is my Z, then I have my Y. Okay, and then I have my Z. X, Z, then Y. Okay, so the sphere that I wanted to draw is this one here. Let me show it. Okay, let me show the sphere. So this is the sphere here. Okay, and then I have that circle on the floor. Okay, I have that circle on the floor that comes like this. Okay, so that would be my sphere. Okay, so we can keep it there. And then now let's work with this one. So this one is the same as Z squared is equals to X squared plus Y squared when you square both sides. Okay, so meaning that I can draw cross sections in the XZ plane and in the YZ plane and also even in the XY plane. Okay, so in the XY plane, I'm going to say, okay, in the XY plane, I'm going to say, let this Z squared be equals to a certain value K. Okay, let this Z squared be equals to a certain value K. Okay, or you can actually just say the same Z. Okay, let's say Z is equals to some value K. Okay, and since Z is equals to the square root of X squared plus Y squared, then it will always be greater than or equal to 0. So this K that we are picking should be greater than or equal to 0 like that. Okay, so it means I have now K squared is equals to X squared plus Y squared. Okay, but this is just a circle with the center 0, 0 and the radius what? K. Okay, the radius there is K. So it means in the X, Y plane, I'm going to see concentric circles like that. Okay, so if I can draw them, so I'll say X, Y plane here. If I can draw them, there's something like this. Okay, so there will be concentric circles like that. So this is what we'll be seeing in the X, Y plane. Okay, so now let's look at the other planes. Okay, so if I go to the XZ plane, okay, what do I see? Okay, what do I see? In the XZ plane, Y is equals to what? 0. So if y is equals to 0, then I have z squared is equals to x squared. This will just mean that plus or minus z is equals to plus or minus x. So these are just straight lines that will be crossing each other like that. So this one in the zx plane, there will be lines going like this and like that. Okay, but since z cannot be negative, okay, anyway, we can even leave it like that. Okay, we can even leave it like that. And then what about in the yz plane? So in the yz plane, we're going to have a similar scenario, but here the x is the one which is 0. So it means I have z squared is equals to x squared, which, okay, I have z squared is equals to y squared, which gives me plus or minus z is equals to plus or minus what? Y. Okay, so these are just, again, straight lines that are crossing each other. So it will be like that and like that. So this is my y, this is my what? Z. So now I can combine what I'm seeing in the xz plane, what I'm seeing in the yz plane with what I'm seeing in the xy plane. So this will just be nothing but a cone. Okay, this will be a cone. Okay, that is going up, of course. So what we are going to do, it's going up because the z there is greater than or equals to 0. Okay, so when we combine these three things, what we get is this. Okay, so when you combine these three things, what we get is this. Okay, so that would be my z, this will be my y, and then that one will be my x. Okay, so when I combine these three things, what I get is this. I have these lines here that are going like that. And then I have these two concentric circles that were increasing, okay, depending on the value of z that you are getting. So they will be increasing until they'll just be going like that along the z-axis, okay, x. So this one is our cone. This one is our what? Our sphere. Okay, so now we want to find the curve of intersection between this sphere and this cone. Okay, so now let's draw. Okay, let's draw the intersection. Okay, so this will be my z, my y, and then I have my x. Okay, so I'm combining these two diagrams now on this. Okay, so what I do here is, first of all, I can draw the cone. Okay, so the cone, it is something like that. What's happening? Okay, so let me use straight lines and then go like that. Okay, so this is my cone here. Okay, so this is my cone. And then on this same diagram, I'm going to put my sphere. Okay, I'm going to put my sphere. So my sphere will be something like this. Okay, my sphere will be something like this. To just be something like that, then like that, like that. Okay, so that is my sphere. So the curve of intersection will be at the point where the cone and the sphere are meeting. Okay, so basically what I'm saying is that it will be at this point. That's where you're going to see your curve of intersection. Okay, you're going to see your curve of intersection. So our curve of intersection, maybe I drew the sphere a little bit in a bad way. So let me draw it in this way. So the sphere will be this part here. Okay. This one will be the sphere like that. Okay. And then the curve of intersection to be there. Okay. So this will be the curve of intersection there. And then there it goes below like that. Okay. So this one in green will be our curve of intersection. Okay, curve of intersection. And then the red one is the sphere. Okay, and then the blue one is the what? The cone. Okay, so this blue one, we can say it's z is equals to x squared plus y squared. And then the red one is our sphere, which is x squared plus y squared plus z squared is equals to 1. We can make z the subject. It will become z is equals to the root of 1 minus x squared minus y squared. So that will be our z. So now, we said once we sketch this, we have to project the curve of intersection down into the what? The xy plane. Okay, so the curve of intersection, if we project it downwards, this one here, okay, we're just going to have a circle like that in the xy plane. Okay, so this here will be the region on which we are integrating this thing about. Okay, so this will be the region here from there to there, from there to there. Okay, so we'll be moving along this region, moving up like that. So now we have to identify the upper and the lower surface. So the upper surface is this one, the red one there. Okay, because it's enclosing this region here, because the region where the curve of intersection is there. And then the down one is this one in blue. Okay, so we are going to say upper is the sphere, and then lower it is the what? The cone. Okay, so we'll be integrating over this region that I've projected to the XY plane, okay, from the lower surface, the cone, to the upper surface, the what? The sphere. So now we have to find this curve of intersection. So how do we find the curve of intersection? We solve these two equations simultaneously. Okay, so that's what we're going to do next. So let's create some space so that we solve it. Okay, so that will be our surface. So we can try to move it. Okay, so let's move our drawing there. Okay, and then find the curve of intersection. So we have x squared plus y squared. Where the z, I'm putting this. So plus the square root of x squared plus y squared is equals to 1. So this will be x squared plus y squared plus y squared. Plus x squared plus y squared is equals to 1. So this will be 2x squared plus 2y squared is equals to 1. Divide everything by 2. We get x squared plus y squared is equals to 1 over 2. So this will just simply mean this will be x squared plus y squared, okay? And then 1 over, okay, it will be, let me not confuse people, the square root of 1 over 2 squared. Okay, so it means this is the circle with center 0, 0, and then the radius, the square root of 1 over 2, which is the same as the square root of 1 over the square root of 2, okay, which will be the same as 1 over the square root of 2, which will be the same as, if we rationalize the denominator to be square root of 2 over 2. So that will be the radius, okay? So it means that's the radius for this circle that we've projected in the xy plane, okay? So it means here of root of 2 over 2, even here to be minus root of 2 over 2, here to be minus root of 2 over 2, there to be root of 2 over 2. So that will be our circle that has been projected. Okay, so remember, we are integrating over that same projected region, okay, coming from the lower surface, which is the cone, to the upper surface, which is the what? The sphere. Okay, so that's what we are going to use. So the projected region, we can even draw it on a separate coordinate axis. Okay, so we can draw our y and our x here with the projected region. So root of 2 over 2. So this is our projected region here, which is in the xy plane. So this region, we can now change it into what? Polar coordinate. We know that this is 0 to 2 pi. This is pi over 2. This is pi. And then this is 3 pi over 2. So this region is sweeping the whole thing from 0 all the way to 2 pi. So it means my theta, okay, is from 0 all the way to 2 pi. And then my radius will just be from 0 all the way to what? To root of 2 over 2. Okay, so we have changed this region into polar coordinates. So what is remaining now is to change the function. So remember we said our volume will be equals to the integral over R, the region, okay, from of the upper surface. So we said the upper surface is the sphere. So we have to make Z the subject of a formula there. So if we make the Z the subject of a formula, we said we have this. So it will be the integral of 1 minus x squared minus y squared over dA minus, okay, the integral now over the same region, but using the lower surface, which is the cone. So it will be R, and then the lower surface is just simply x squared plus y squared dA. So since we are changing to polar coordinates, it means my dA will turn into what? Jacobian dr d theta. So r dr d theta, this one here. And then I can see that this one here under the root it can be 1 minus x squared plus y squared. And we know that x squared plus y squared in polar coordinates, that's just what? R squared. So what we have here is that, okay, the region now we can put the limits according to the polar coordinates. This is 0 to 2 pi, okay, 0 to root of 2 over 2, and then this one will be the square root of 1 minus r squared, okay, this part. Then the dA has become r dr d theta minus, okay, over this same region, 0 to 2 pi, 0 to root of 2 over 2, and then this one here, x squared plus y squared, that's just basically r squared. So what is the square root of r squared? It is r. And then the Jacobian r, and then dr d theta. So this here will be our volume. So now what we are remaining is just to simplify this and evaluate it. Okay, so let's do that. Okay, so I can now erase this this region here. Okay, so we can now say that our volume, okay, our volume is equals to, so we just have to integrate this and then subtract them, right? Okay, so we can start with the first one. So let me even erase the volume. So what is this integral here? So this integral, we are going to evaluate it using substitution. Okay, we're going to evaluate it using substitution. I want to say that u equals to 1 minus r squared. So it will mean my du will just be minus 2, okay, to be minus 2 r dr, like that. Okay, so I can replace this r dr. So I can make the subject of a formula there. I'll say r dr is actually equals to minus du over 2. Okay, minus du over 2. All right, and then what else am I going to do? I'm going to change the limits. Since u is equals to this, it means the first limit there, okay, the first limit there becomes, okay, because I'm considering these limits for the r. So this limit, okay, I'm going to say if my r is 0, then my u is equals to 1 minus 0 squared, which is just 1. And then if my r is root of 2 over 2, then my u will just be 1 minus root of 2 over 2 squared. This will be, this will just be 2 over 4. So that will be half. Okay, so my limits have changed to this. Okay, so now I can try to substitute. Okay, so I have 0 to pi. Remember, I'm just evaluating this one first, and then I'll evaluate this and then subtract to find the volume. Okay, so it will be from, okay, from 1, because this limit here has changed to 1 there. Okay, then this limit on top has changed to half. Okay, so here we have like an improper integral because we are moving from a bigger number to a smaller number. Okay, and then there in the square root, I'm going to have u. So that would be like u to the power half, right? Okay, because 1 minus r squared, we said it was u. And then r dr, okay, has become minus du over 2 and then d theta. Okay, so what will happen here is that here, this is an improper integral because we're coming from a bigger number to a smaller number. It always has to be from a smaller number to a bigger number. So we switch these limits. Okay, so when we switch those limits, it means we introduce a negative in front. So it will be minus and then half, okay, and then to 1. And then I have minus 1 over 2 u 1 over 2 d theta. Okay, I've forgotten the du. Okay, du d theta like that. Okay, so from here now, I see that I can multiply this part, okay, the minus 1 over 2 with the negative there. So what I get is, okay, I get 1 over 2 outside, and then 0 to 2 pi, and then integral half to 1, and then here I just have u to the power half du d theta. Okay, so that's what I have. So we can actually evaluate that. Okay, so let's evaluate it. Okay, so what we have there, we're going to say I have half 0 to 2 pi. So if I integrate u to the power half, I get u 3 over 2 over 3 over 2, and then the limits are 1 and half. Okay, and then from there, we just have to substitute. Okay, we just have to substitute. But this 3 over 2, we can multiply it with this 2. So this 2, okay, it's like 1 over 2 multiplied by, this one is 1 over 3 over 2. So this 2 and this 2 cancel out. So I only remain with 1 multiplied by 1, 1, and then 1 multiplied by 3. So it means outside the integral, okay, let me not forget to put the d theta. Outside the integral, what I have now is 1 over 3 from 0 to 2 pi, okay? And then I've already dealt with the one that I had outside. I just have u 3 to the power, u to the power 3 over 2, and then the limits are 1 and half, and then d theta. So what I get there is 1 over 3, 0, 2 pi, okay? This one now here, I'm just going to substitute. So if I substitute 1 into this, I just get 1 minus. If I substitute half there, okay, what I get is half to the power 3 over 2. Okay, so this is the same as what? Okay, this is the same as, okay, this is the same as the cube root, I mean the square root of 1 over 2 multiplied by 3, this thing here. Okay, so it would be like the square root of 2 multiplied by the square root of 1 over 2 multiplied by the square root of 1 over 2 multiplied by the square root of 1 over 2. This is what we have. So this square root and square root cancel out. So I have half. Okay, and then multiplied by the square root of 1 over 2, which is just the same as 1 over this, the square root of 2. So I have 1 over the square root of 2. So this will just be 1 over 2 square root of 2. So that's what I write here. Okay, so I'm going to write here that I have 1 over 2 root 2. Okay, and then it will be d theta. Okay, and then once I do that, I can actually integrate now with respect to I can integrate with respect to d theta. Or maybe we rationalize the denominator here. So I multiply by the square root of 2. Even there, I multiply by the square root of 2. So what I get is 1 over 3, 0 to 2 pi. Okay, so here I'm rationalizing. I multiply with root of 2 there down, I'm going to get 4. And then on top, I'm going to get root of 2 over 4. So I've rationalized the denominator there and then d theta. Okay, so now let's evaluate this. So it will be 1 over 3. And then this one will be theta minus root of 2 over 4 theta. And then 2 pi 0. So this is what I have there. Okay, so remember this is just the part for the first part of the integral. So what I have is 1 over 3. And then here I substitute. So I have 2 pi minus root of 2 over 4 multiplied by 2 pi. Okay, multiplied by 2 pi. So what do I get there? Okay, I get, I can try to expand this with the 1 over 3. So I get 2 pi over 3 minus, okay, here the 2 cancels out with 1, 2 from the 4. So I have root of 2 over 2 pi multiplied by this 1 over 3. So that will just be, okay, it will be pi root of 2 over 6. Okay, so this is the integral for the first part. So this part here has given us pi, 2 pi over 3 pi root 2 over 6. Okay, so let's now find the other part of this integral. Okay, so we can write whatever we found for this part as 2 pi over 3 minus pi root 2 over 6. So minus, now we're evaluating this guy here. Okay. So if we evaluate that guy, okay, what are we going to get? So it will be 0 to 2 pi, okay, and then here, this is r multiplied by r, so I have r squared. So now I can integrate, okay, with respect to r. So I get r to the power 3 over 3, and then the limits there are just 0, root of 2 over 2 d theta. So this will give me what? Okay, let's substitute. So it will be 0, 2 pi. Okay, if I put this root of 2 over 2 to the power 3, what do I get? Okay, what do I get? So it will be root of 2 multiplied by root of 2 multiplied by root of 2 on top, and then down it will 2 multiplied by 2 multiplied by 2. So down there, I get 8. Here on top, I get 2 root, I get 2 root 2. Okay, that's what I get. So I'm going to put 2 root 2 over 8, and then multiplied by this 3 that was there already. Okay, so 3. Then if I put 0 there, to just be 0. So this will be d theta. So what I have is from 0 to 2 pi, okay, of 2 root 2 over 24 d theta. So now we can integrate with respect to theta. I get 2 root 2 over 24 theta, and then 0 to 2 pi. Okay, so that's what I get. So I can substitute there. Okay, so it will be 2 root 2 multiplied by 2 pi over 24. Okay, so this will be 4 pi root 2 over 24, which is just pi root 2 over what? 6. So the integral for this part, it's pi root 2 over what? 6. So now we can substitute those two integrals that we found to get the volume between these things. So the volume, the final volume, will just be equals to 2 pi over 3 minus pi root of 2, 6, minus pi root of 2, 6. Okay, so that's what we get there. Okay, that's what we get there. Okay. All right, so let's combine these. So we are going to say let the common denominator be 6. So 3 into 6, I get 2. So 2 multiplied by this guy, I'm going to get 4 pi minus, here I'm just going to get pi root 2. And then, okay, I'm also going to get minus pi root 2 even there. Okay, so let's simplify this one. So this one, we are going to say this is the same as 4 pi minus 2 pi root 2 over 6. Okay, so let's factorize 2 pi over 6. So 2 pi over 6 comes out. So what I remain with on top there will just be a 2 minus root of 2. And this will be the volume. So the units, they will be cubed like that. All right, so thank you so much for watching. That is our final answer. I hope you enjoyed the video.